Hi everybody, today we are going to review what we already know about circles and then we're going to continue and learn some new things. First of all, you probably know that if you start from one edge of the circle, go through the center and go all the way to the other side, then you have just traced the diameter like we have in this diagram here. If you start at the center and go out to the edge, you have a radius. A radius is half way across. It's always half the diameter. If you want to talk about going all the way around the circle on the edge, you're talking about circumference. So those are three vocabulary words that you probably already know. But I think I want to review how we name things. To be able to name things, you usually have some letters. And let's call this A. We'll put a B here for the center point. We'll put a C out here on this edge. We'll put a D up here for these points, and I'll just outline the points right there for you so you know what we're talking about. Now, first of all, let's find all the radii. So a radius, if you want to say more than one radius, it's a radii. So two eyes like that. All the radii are formed when you go from the middle of the circle all the way out to the edge. So you actually have three radii right here. You can talk about AB. You can talk about DB. And you can talk about CB. And all of those line segments are radii. You only have one diameter here, and that is A, and you want to go all the way to the other end point, so that's AC. So if you wanted to name that diameter, you would call it line segment AC. If you want to name this circle, circles are always named by their midpoint, their center. So if you go here, the center letter is B. So we could say that that circle is called circle, here's the symbol for it, circle B. Okay, now this is the old stuff, here's some new stuff. Now we're going to talk about arcs. Now arcs are pieces of the circumference. They have endpoints, and this right here that you're looking at that's labeled 45 degrees in dark blue, that's an arc. Now let's give it some letters because we want to be able to name these arcs. So the end point of the arc, let's call this M. We'll call this N. We'll call the circle O, so we'll give it a middle. And let's put a point out here on the edge and call that P. So now we can be able to talk about our different kinds of arcs. So an arc is just basically a piece of the circumference. It has an end point. You have in a circle, you usually have some major arcs and you have some minor arcs. First of all, let's talk about the minor arcs. Minor arcs are less than 180 degrees. They're the smaller ones. So if we're looking at the arc M to N, it's labeled as only 45 degrees, plus it's not half the circle, so it's less than 180. The minor arc here that we're talking about would be arc MN. And you can draw the arc symbol above the MN like that. You also have major arcs. Major arcs are bigger than 180 degrees. And it's everything that that minor arc would not be. So if I started at M, I would go the other way through P all the way back through N. Major arcs need 3 letters to name them because it shows you that you're going the long way around the circle all the way back to that M. If you just named it MN, you'd think it was a minor arc. But if you call it MPN, you'll know it's the major arc. One of the interesting things and useful things to know is that the central angle, like is marked here in blue, is always the same as the intercepted arc. So this angle, we'll call this angle, there's a symbol for angle, M-O-N. Angle M-O-N is always going to be the same as the arc that it intercepts. So you can say that angle MON equals arc MN. Or you can also say that they are both 45 degrees, as the diagram shows you. Okay. All right, let's look at how we can use some of these things in math problems. So we see that our arc here is 50 degrees. We would also know that if the arc is 50 degrees, then the angle that it intercepts, or the arc that it intercepts, is going to be the same. So this C to B is going to be 50 degrees. And that makes sense, doesn't it? Because we can measure the angle from 50 degrees right here, and it'll be 50 degrees. Or we could measure it a little farther out, and it's still 50 degrees. Measured a little farther out, it's still 50 degrees, and eventually you'll hit the arc, and it will still be 50 degrees. So minor arcs are always the same as their central angle. Now here's an interesting thing that you can remember from when we did triangles and other angles. If you have those vertical angles that are formed by two straight lines crossing, remember that X makes two angles on the left and the right that are the same. So this angle right here would be 50 degrees as well, which also means that its intercepted arc would also be 50 degrees. Now this one, from D to R to E, let's name that angle DRE. It's told us, the diagram tells us that it's 30 degrees. We know that it equals its minor arc, so angle DRE equals arc DE, and both of them are 30 degrees. Okay, now here's a larger angle, but it's still just a minor arc because it's less than 180. This angle from D to R to C equals the arc that it intercepts. So it intercepts arc DC. Do you notice that the angle and the arc have the same end points? DRC, arc DC. So that's another way you can remember they are the same. They have to go through the center, though. It has to be a central angle to be the same. They're both 100 degrees. Now we can do a little math. We know that a whole circle is 360 degrees. So if we take 360 and we subtract all the angles that are given to us, we've got a 50, a 100, a 30, and we figured out that this angle ERA is 50. We subtract all of those, so taking away 50, taking away 30, taking away 50 again. If you do that math, you'll find out that what is left here would be 130 degrees. So we've just figured out what this last angle is by subtracting from 360. And of course, that means if ARB is 130, then AB is 130 as well. So I'll just write arc AB is 130 degrees.